I'll be covering 4 different data sets today, from EIA, FERC, and CEMS, and EPA. And so yeah, let's get started. So just a bit about who we are to give you some context. This presentation is being run by Catalyst Cooperative. We've been really scraping, cleaning, connecting, publishing open source electricity data since 2018. We were really frustrated by the amount of data processing that was necessary in order to be able to answer like really fundamental and rudimentary questions about our energy system. We do that through the Public Utility Data Liberation Project, which integrates EIA, EPA, FERC, and NREL A2B data, as well as a couple other data sets. The data sets that we're going to talk to you about today are ones that we've worked with for a number of years. They're really at the core of what we do, and we're really excited to nerd out with you about like the niche details of the gritty problems with each one. So with that, I'll talk a bit about the broader program that this is part of. This seminar is part of a broader programming series that's funded by the Sloan Foundation. The goal is really to develop foundational data and software engineering for early career energy researchers, which hopefully is many of you. We're running a number of programming streams. So this is part of our online seminar series, but we're also working on developing an interactive Python tutorial and hosting a 2-day interactive data lab in the fall of 2025. I'll talk at the end of the presentation about how to stay informed about all of the other streams that we're working on, as well as future seminars. So stay tuned for that. But yeah, today we're going to be talking about 4 data sets that we've been working with extensively: EIA Forms 860 and 860M, EIA Form 923, FERC Form 1, and the EPA Continuous Emissions Monitoring System. And then we'll talk somewhat about how to connect these different data sets to one another. We'll leave lots of time to ask questions, so we'll have a Q&A after each data set. If anything's unclear, if you want more information about anything that we've talked about, feel free to ask. We'll try to answer as many questions as we can. And then we'll have kind of time at the very end for Q&A if there's anything else you want to talk about. Great. In terms of what we'll cover, so for each data set that we talked about today, we'll talk about like what information is actually in the data set, so what variables are available to use. How is the data collected? When we spend time talking about this, we think it's kind of like an under-discussed part of data, and we don't think about it that much more like downloading a spreadsheet. But the process behind the creation of the data, who's involved, and their motivations, we think is like really informative to the quality of the data, the kinds of errors you'll encounter when you're using it, the willingness of the provider to like answer questions or correct issues. So that's something we'll talk about for each data set. We'll talk about like the geographical coverage. So is it like a state or is it the entire US? As well as how far back in time the data goes. And then we'll also talk about the level of detail. So what is the smallest unit in time and space? Like, for example, like a row might represent like 1 month of data for a single boiler in the plant. Finally, we'll talk about how often the data is updated. We'll give you a couple of examples of how people are using it, just to give you a sense of like the kinds of questions you can ask for each of these data sets. We'll talk some about notable irregularities, so like challenges in data quality, format, things like that. That'll be useful to know if you're planning on working with the data. And then we'll also talk about how to access the data as well. And I'll note that there are links in the slides. We're going to share these slides with you after the presentation, so there's no need to write them down. Don't rush to write down HTML links or anything. We'll share the slides with you. So I'll just say that. But with that, I'll hand it over to Austin to talk about the EIA data.
Awesome. Thank you so much, Ella. So we're going to start by talking about some of our favorite forms from EIA, the 860 form, or the Annual Electric Power Industry Report, and the 923, the Power Plant Operations Report. So the Energy Information Administration is primarily a data collection and distribution entity. It's a part of the Department of Energy, but its primary role is to disseminate information. So that means, luckily for us, that it is relatively amenable to work with. It has good data practices. It is transparent about the information that's in there. It updates the data regularly, and it makes it relatively user-friendly. It was actually established in the 70s after the oil crisis and a need for more transparent information about the energy sector. And there's about 50 different forms that EIA manages, also known as surveys, and all of them are published as CSVs for download on their website. They also have an API if you're a little bit more technically savvy and want to interact with them that way. So let's dig into 860 first. 860 contains plant attribute information. So this is more static, slow-moving information like plant name, plant data like capacity, generator information, ownership information, some construction cost information, and then some boiler and equipment association information. So the connection between boilers and generators in a given plant. It's filled out by owners of plants that are more than 1 megawatt of capacity and connected to the grid. So it's not 100% comprehensive. You'll see, for instance, like smaller scale solar or hydro or generators connected to, specific buildings excluded from this data set, but it's relatively comprehensive. And there's a separate form called the monthly update to the annual electric generator report, or the 860M. And this is for entities that anticipate a new input of information on a sub-annual basis. So if there's a new generator, a modification to a generator, or a retired generator that wouldn't be reported or that is newly reported within the calendar year, they would fill out the 860M form to make sure that there was up-to-date information about that particular change. But in general, this form has annualized information that's relatively slow-moving and static. So some key attributes for this form: the geographic coverage is the US. The time coverage is 1990 through present, so it goes back pretty far, though it's worth noting that the form has changed since the 90s and is relatively consistent starting in about 2013 onwards. But there's some fluctuation in what was actually asked of the reportees over time. The time detail is annual, so when you're opening up the tables, you'll see information by year. And then the reporting detail is power plants and generators. So each row of the table is going to correspond either to a power plant or a generator, depending on the table that you're looking at. The update cadence, again, is annual for this table, and the licensing is US government works, meaning that you can use and republish the data as you wish. Comparatively, the 860M is a newer form, so it was started in 2015. The detail is also annual, but again, it's at a monthly update cadence so that we can get that information about updates to plants on a sub-annual basis. But similarly, reporting detail is power plants and generators, and licensing is the US government. Awesome. So how is the data actually collected? The most common method of inputting information to EIA is through their e-filing system, which is great. This hasn't always been the case, however. So back in the 90s, people were filling this out in a totally different way. So you can expect the older information to look a little bit different from the newer information. But having this e-filing system is great because it does allow some safeguards when inputting information to make sure that you're not spelling things wildly incorrectly. And that the EIA has an opportunity to vet the information at a little bit of a higher quality assurance than if it was just written. You can see at the top corner here, very, very small, but the anticipated time to fill out the form is 16 hours. So there's a lot of information in here. It's really meaty. And it is quite a burden for these entities to fill out on an annual basis. So you can imagine too that there might be some complexity with regard to the information in here simply based on the time that it actually takes to fill out. And then, believe it or not, you actually still can submit a written form if you want to print out the PDF and handwrite it. You can. I don't know if anybody does that, but it is still allowed. And so that is something to take into consideration when handling the data. The final data, as we mentioned before, is distributed as CSVs on the website on a yearly basis. You can see in the screenshot down here, this is what it would look like to download. All right, moving on to 923. This form collects a bit more dynamic information about power plants. So whereas 860 is information like plant names and capacity, this form contains things like fuel receipts and costs, generator data like fuel consumption, fuel stocks, non-utility sources of energy, and some environmental data. It's filled out also by plant owners, similar to 860, but it has more of a monthly cadence than the 860 form. So a lot of the information, like for instance, fuel consumption, will be reported at a monthly basis. Larger plants are required to actually fill that out on a monthly basis and report, whereas smaller plants only have to report at an annual basis. So essentially at the end of the year, they'll report month by month all of their consumption information, whereas the larger plants actually have to report on that monthly cadence. And the monthly form is a little bit shorter than the annual form. Key attributes of this form are it's also United States, also started in 1990. The time detail, again, is dependent on the actual table within the form. So some of the information is monthly, and some of the information, like the environmental data, is more annual. The reporting detail is US power plants or generators, again, so each row in those table is going to correspond either to a plant or a generator entity. The update cadence, annual or monthly, and the licensing is US government as well. So similar to 860, this data is curated on an online e-form. And you can see here some examples of how the form might warn you to input correct information. If you want to hop on the next slide, yeah, you'll see if you were to go and put a boiler ID in here, it actually says, hey, make sure that this corresponds to what you put in 860, which is great for us because anyone attempting to actually connect those data sets can be a little bit more assured that they're really referencing the same entity. And here's another instance for energy source. If you were to fill that out, you are prompted to select from a drop-down menu of options as opposed to writing in something at will, which you can imagine might result in a large array of slightly different spellings and interpretations of the meaning of energy source. The e-form also enables EIA to vet the information, and they will contact respondents occasionally if there's anomalies that are detected. Some cool examples of this are in 2019, Vibrant Clean Energy released this report called the Coal Cost Crossover. And essentially what it was doing is comparing the cost of current fossil fuel coal energy with new solar and wind and seeing if it was an economically viable alternative in addition to being an environmental alternative. And basically what they found is that by 2025, up to 86% of the existing coal could be replaced by renewables at a better cost to consumers than the existing coal, which is pretty cool. And this study relied on 860, 923, and FERC data, which we'll talk about in a minute. So now we get to get into our favorite part, the nitty-gritty of what is wrong with the data or what interesting challenges we face as curators of the data and as republishers of the data. So one thing that we find is interesting is that the EIA publishes this data on an annual basis and releases zip files containing files for each of the schedules within the form. And so there's a lot of knitting together of information that has to happen if you want to process a historical version of the data. Say you wanted to review the capacity or net generation changes over time, you would have to configure these tables in a way that would be chronological and could be difficult if you were looking at one CSV at a time. Another issue is the change in layout of the raw published data. So this could be due to the form itself changing. It could also be due to the publisher deciding that they want to change the column name, or a human error again in how that data is republished, because they're taking inputs from a form and they're turning that into a CSV that is then republished. So there's going to be a little bit of difference between, if you saw that first screenshot, it doesn't look like a table. There's inputs where you can put in information, but it doesn't read like a CSV. So they need to convert that to something that's more widely shareable and contains information from all the respondents. So this screenshot is an example of PUDL's mapping of one of the EIA tables across time. And as you can see, the blue indicates times where a column didn't exist in different years or is blank. And then the yellow is an instance where the column name changed. So it was referencing the same data point, but it was spelled differently or referenced differently. There's a whole bunch of others that we can get into here too. One being estimated data. So in the event that a respondent doesn't fill out the form, even though they're legally obliged to, the EIA will input estimated data. And so that's something to be aware of when you're trying to get down to the nitty-gritty of specific plants or aggregated data, understanding there might be estimates in there. Another is redacted data. There's instances where, for privacy reasons, a plant's information won't be associated with its name. So it'll have like an 8888 ID instead of its actual correspondent ID for privacy reasons. Another is revised data. So occasionally, if a filer notes that there was an error in a previous year, they can go and revise that. But that means that if you, as a user, are downloading data on an annual basis, you might not actually receive or get that updated data if you're only paying attention to the most recent year of released data. And EIA doesn't actually inform people that they've made these updates. So you just have to sort of download the data and anticipate that there might be some changes, which is kind of tricky, and is one of the things that we've been working on in PUDL too. And every time we pull the raw data, we make sure to pull all the years just in case there are some updates that we didn't notice. Another is static values changing over time. So as I mentioned with 860, a lot of that information is characteristic of the plant and in theory wouldn't change. However, with ownership changes and modular changes to plants, sometimes things like plant name or capacity can change. So it's important not to assume that some of this information that seems like it wouldn't change, because it does. Everything changes. Another is incomplete associations. So in the 860 form, there's a table, for instance, that corresponds boilers to generators. And it would be easy to look at that and think that that was a complete association table. However, we as ingesters of lots of EIA data have noticed that this association table does not actually show all of the links between boilers and generators. It's representative of all of the megawatts that are reported in other EIA tables. So it's very tricky to know whether a data set is definitely complete just by looking at one table alone. And lastly, not all data is actually reported at the same detail. So for instance, you might have one table that reports interesting information at the generator level, and another table that reports relevant information, but at the prime mover or energy source level. So it's difficult to compare, contrast, or combine that information. All right, if you are inspired to use any of this data, you can go and download the raw files from EIA. These are all links. Or if you're interested in getting our knitted historical PUDL data, all the years in one, you can also download that from the PUDL SQL database. And there's some instructions on our website and our documentation page as to how to do that. Awesome. Does anybody have EIA questions that we can tackle? Okay, it looks like we've got some already. What kind of data is available on technical characteristics of different plants that constrain their unit commitment? What do you mean by unit commitment? I'm not sure I understand that. Let's see, what else? Okay, the question about the monthly 923 data only for a sample of large plants. Yes, that's true. And yes, the estimated data is identified by the 9999 plant ID identifier. Awesome. Cool. Thanks, guys. If you think of any other questions related to EIA, feel free to ask those in the chat at any time, and we can circle back. What information in the EIA 923 about coal mine productions? I don't know that off the top of my head. All right, cool. We'll grab the rest of these questions and circle back to them later too. And I'll hand off to Christina.
Thanks, Austin. Yeah, hi everybody. My name is Christina. I'm going to be talking about FERC Form 1, which is simultaneously my favorite data set and also the most frustrating of the data sets we work with regularly. So FERC is the Federal Energy Regulatory Commission. As the name implies, FERC is a regulatory agency. It's an independent arm of the Department of Energy. Similar to EIA, it was also created in the 70s after the oil crisis. And their mission is to regulate the electricity, natural gas, and oil markets in the US. They largely cover the interstate transfers and markets. So they're largely making rules, rates, and doing permitting for things that cross state lines. So they, in the electricity space specifically, they regulate transmission and wholesale markets. And a lot of their work is done through these quasi-judicial regulatory proceedings. And I'm noting that mostly because in those proceedings, expert witnesses from utilities or interest groups come with data and facts, sometimes FERC's own data, in order to make cases, and then either the judges or commissioners in those proceedings will make decisions based on those facts. And that is like the primary function and movement of FERC, which contrasts pretty greatly to EIA as a data agency. But FERC does collect and publish a lot of data. And so, yeah, we're going to talk about FERC Form 1 in particular. Form 1 is a comprehensive financial and operating report that covers large electric utilities in the US. There's about 70 schedules, which in FERC's language is effectively a table. So it's pretty sprawling. It covers a lot of information. We're primarily going to be focusing on power plant tables and accounting tables. The power plant tables, I think, are particularly interesting because they have data in them that is reported in no other place in like a comprehensive format. In particular, the operational expenses of power plants. So as Austin mentioned, the EIA data has a lot of good, nice and clean, well-structured data about fuel costs of plants and fuel consumption. But FERC Form 1 publishes all of the non-fuel operational costs as well, including like staff expenses and heating and cooling expenses and anything else that any other costs that they have to run the power plants. There's also a lot of detailed annual data about capital costs, which together the operational costs and capital costs are like the full actual costs of running and operating these plants. There's also like really the bulk of Form 1 is accounting tables. And those accounting tables have a lot of detailed information about utility assets and liabilities. Most of the tables are structured and use the FERC's Uniform System of Accounts, which is a federal accounting standard for utilities, which provides a lot of granular, detailed information about the transmission system, the distribution system, and the production system. FERC requires, for Form 1 in particular, requires major utilities to report to Form 1, which there's various thresholds for what makes up a major utility based on sales, resales, or exchanges annually. But generally speaking, this covers a large swath of the US in terms of electric generation and like ratepayer sales. But the small municipal utilities and the small like rural electric co-ops that don't meet these thresholds do not need to report to FERC. So there is a fair amount of gaps, especially in the context of smaller utilities. Great. So some like general attributes of Form 1. It also has US geographic coverage. It has been being collected and reported since 1994. Most of the data in FERC is annual, although there's some quarterly data. The level of detail in FERC varies across its 70 tables. Most of it is at the utility level. But as I mentioned, there are a handful of plants that are at the plant or subplant level, and we'll get into them later. And there are also a handful of plants, or there's a slew of plants that cover varying levels of the transmission system. Some are at the like transmission system level, and some are like at the transmission line level. So there's a variety of reporting detail levels in Form 1. And FERC is updated on an annual basis as well. They do a rolling submission process. So whenever they get a Form 1 filled out from a utility, from an operator, then they then republish it. Generally speaking, about midway through the year, they have published. FERC has republished all the full previous years of data. And it is also, like everything that we're talking about today, a US government work license. So it is free and open to use and republish. Oh, yeah, okay. I'm going to go into a few examples of folks using FERC Form 1 data in the wild. So you can get a sense of like what kinds of questions you can answer with this data. The first one that I'll cover is from RMI's Utility Transmission Hub. The Utility Transmission Hub is an interactive data portal that is attempting to ask the like broad question of whether or not utilities, as like individual utilities or the utility sector writ large, is on track to meet any climate goals. And in particular, the finance tab of the hub is entirely fed by FERC 1 data. And this finance tab in particular, there's a screenshot of it, but it is trying to ask the question of which technologies are utilities actually invested in and how has that changed over time, to try to attempt to answer that bigger question of whether or not they're moving away from fossil fuel investments or not. And you can look at this from many different years and for individual utilities or for the whole industry. Another two examples are a paper that was published by mostly some folks at NREL that looked at trends in the utility sector from 1994 until 2019 about how utilities were invested in transmission, distribution, and admin costs. I mostly note this because they, alongside their paper, they also published just an Excel data sheet that was their cleaned up data that they use to do a lot of this analysis, which is a helpful way to like poke around and look at what types of data is in Excel or is in Form 1 in a cleaned up and like slightly more accessible way. Another another example of FERC 1 data in the wild is a paper that Energy Innovations published this past year. They were trying to understand whether or not clean energy was driving increase in electricity prices. And from a variety of sources, they found that that was not the case. But in this particular instance, from the figure that I'm showing, they were using Form 1 data to figure out which portions of utilities system they had been investing in more over time, and they were like from the FERC 1 data shows overall the transmission and distribution sectors have been growing more over time, and that was all done with Form 1 accounting table data. So similar question to EIA, how is FERC data curated? So FERC does have a ton of instructions for utilities about how to fill out the forms mechanically. But basically FERC gets the filings, submissions from these utilities, and if it fits the schema, they then publish that data, which leads us into a bunch of inconsistencies and challenges with the Form 1 data, because the Form 1 data is generally speaking entirely manually generated by these respondents. And there is across the board a lack of validation, which leads to a bunch of wacky hijinks in the data. Across the board, there are a lot of free-form text fields in Form 1. So unlike EIA, where that Austin showed, there's a little like drop-down menu for their energy sources, and you can't enter anything else. The folks that are entering data into a Form 1 can just like kind of enter in whatever. They generally, honestly, do a pretty decent job, but because there are no restrictions, people, the respondents interpret the prompts quite differently, and that makes it relatively challenging to, with the raw data, to like to ask interesting questions across multiple utilities, or even across a single utility across multiple years, because there are not restrictions on what they can enter. And even in like this kind of plant, they give some suggestions about what to enter into this field, but there are no definitions of what those things are, and there's no restrictions on them, unlike in the EIA context. There are also a slew of nulls across the data set, which is pretty typical with data sets in general, but there's not a lot of documentation or communication about why those nulls, or how what they're supposed to mean and how you're supposed to interpret them. Also, another symptom of having a bunch of free-form text fields in a form that there are a bunch of letters and words where there should probably be numbers, and vice versa. There's also a fair amount of instances in which it's pretty clear that a utility is entering dollars when they should be entering thousands of dollars, and on and on. There's a bunch of these quirks in the data that just happen when utilities manually enter data into a form for 30 years. Great. Another fun thing about FERC is the formats that FERC has been reporting many of their forms in. So from 1994 to 2020, Form 1 has been reported as DBF files, which if you probably don't know what that is, because it's an antiquated database format, and it has been relatively antiquated for quite some time. So certainly certainly way before 2020, it was an antiquated data format, but they did change their format in 2021, and they transitioned to publishing Form 1 data and a lot of the other forms as XBRL data, which is the Extensible Business Reporting Language. It's certainly much more of a modern data format than DBF, and there's many more tools that support interacting and using this data than DBF data, although it is not particularly widely used or like familiar with a lot of data practitioners. The main use of XBRL right now is actually from the Security and Exchange Commission. And there is some logic behind FERC choosing XBRL because it's primarily used to report accounting and like business logic data. So which for Form 1 in particular has a lot of. I will note that somewhat unlike EIA, where the form changes every now and again, the actual content of the form basically hasn't changed over the full life cycle of when they've been reporting Form 1, which is nice in a lot of ways. Because it is possible to stitch together the old DBF versions and the new XBRL data, despite it like structurally changing pretty dramatically. But the like content is all the same, which is a bright spot. Okay. Another set of like challenges with using Form 1 data is that there's just generally speaking a lack of IDs across Form 1. And the main ID that is reported in FERC Form 1 is the like respondent ID, so like who is reporting the data itself. And but everything else kind of just doesn't have IDs. So in the case of EIA, when an operator is even proposing or thinking about building a plant, that plant gets an ID, and that ID lives with it for the full life cycle of that plant, and it shows up in any table in any year. Any information about that plant that EIA publishes is going to have the ID associated with it, and that is nice because you can knit the data together. FERC just doesn't do that. So, and in combination with the free-form text fields, even for things like the plant name, that can be quite challenging. It's a challenge that you have to overcome if you want to work with the data across time and across tables. So this is an example of Duke's steam plant table, and just the like first little snippet of their table. There are three like chunks of the Asheville, like portions of the Asheville plant that Duke is reporting here. And from 2023 to 2020, they use a different string, or they use a different name. And there are a lot of attributes that are reported in these tables. So it is possible to link these various records. It's possible to link Asheville CC with this third Asheville that is reported here, but FERC doesn't help and do that work for you. It's also hard sometimes to link it even between tables in the same year. So this like the steam and fuel table are all referencing the same plants, and in this context, Duke did report the same name for these plants, but again, FERC just doesn't report IDs, so it doesn't like do the thing that a lot of data publishers do to make it easy to knit data over time and across tables. Another quirk of FERC Form 1 is that there are a lot of tables, and particularly the accounting tables, where there's a lot of nested data and embedded totals and subtotals. This is an example of Duke. I'm picking on Duke. This is an example of Duke's summary of utility plant data, which is one of their like key asset tables in the slew of accounting tables. And this is just the very top of the table, and it's just a snippet of it. And there are 3 totals within these first 15 lines. So this first total is a total of the handful of the lines above it. This second total on line 13 includes line 8 and everything else in between. And then which is a total which includes another total. And then line 15 is actually line 13 minus line 14. This kind of reporting is this kind of reporting which has like calculations or subtotals is very common in accounting in general. If you see accounting reports, they often have subtotals embedded in the form itself. As a data practitioner, this is very challenging because, and it's something to be aware of because there's a bunch of duplicate information in one column, and it's you have to be careful to make sure that you have the no duplicate information if you're trying to ask questions. Luckily, with the transition to XBRL, FERC did publish a lot of these calculations and like of relationships between the fields in the metadata that they published with Form 1, which is very nice because some of these relationships between these tables get quite complicated. So this is just a quick snapshot. I'm not going to explain it deeply, but this is a quick snapshot of the relationships and nested calculations between 4 of the like key accounting tables in Form 1. That and as you see, they're like it's a quite complicated nest of how tables are related to each other and how within tables fields are related to each other. So we're really glad that FERC did start publishing the calculations of this metadata because it makes these tables much more usable. It would be awesome if they actually checked if the data in these calculated fields were calculated properly. They do not do that, but FERC does, or the utilities actually do a wildly good job of reporting that those calculated fields, considering that that data isn't validated. So there's a ton of other inconsistencies and challenges within FERC that I don't have time to go over, but generally speaking, like FERC has a ton, it's like a treasure trove of financial data about utilities, but it's certainly a data set that is to be a little bit that you have to be a little bit wary of before answering questions, just to make sure that the assumptions that you might have about what a clean and nice data set should look like, you have to question those with FERC and make sure that but before you actually jump into any analysis. Great. Here are some links, which again we'll share these as a spreadsheet, as a slideshow, but I want to just note, more than any other of the data sets that we work with, I do not recommend that you go to the original raw data sets here. If you care about any of the tables that in the 20, we at Catalyst have cleaned and republished 23 of the FERC Form 1 tables, and if you care about data in those tables, I highly recommend that you just start with PUDL, in large part because of the like data format challenges and all of the inconsistencies that I've just gone over that we have attempted to solve or attempted to like bring solutions to. But you certainly can jump into the raw data if you'd like. We have also converted the raw data into SQLite databases, so we don't do any data transformation in those instances, but it's just knitting together all of the submissions and all of the years and just republishing in a more accessible data format. I will note that if you want to look at an individual utilities filing for Form 1, the submission viewer for the XBRL data is a totally good way to go. And if you're curious about like the structure and schema of the tables, or if you're curious about any of those relationships between the records, the schema viewer from XBRL is also a nice place to look. And just as a reference here, these are some tables that both the power plant tables have schedule numbers and the transmission tables. This is just a reference. All of the raw tables, PUDL tables, and all of the tables in the like HTML or PDF versions all use the schedule numbers. So it's a nice reference across these tables. But if you want to go look at those tables in particular, those are the numbers. That was a lot. I hope I didn't scare you away too much from Form 1 because it is a fun data set. But yeah, does anybody have questions? I will try to answer, Bailey, your question. The question is, does FERC Form 1 include revenue, profit on any level in addition to the costs and expenses? They do include revenue, and you can assume they don't actually include profit that they in Form 1, but it's not straightforward, but it is calculable from the like assets and expenses. Just because like basically across the board, utilities have rate-making proceedings with their state regulators, and there are federal standards for what is allowable to include in their rate-making processes. And generally speaking, they get a cost plus a rate of return on their and that's their profits. And so it is calculable, but it is not reported, is the long answer to, or is the short answer to your question. But I'm happy to talk more about that because we have done some work to play around with the rate bases for utilities. Yeah. And there's a question here that says, have you looked at the geospatial data published by these organizations? And I will answer briefly for EIA and FERC. FERC Form 1 in particular reports no geospatial data. There's plants and there's a bunch of data about like infrastructure that is obviously like in the world, in space, but they do not report anything about that about where those where that physical infrastructure is. EIA does report the lat long for every single generator that they report. Yeah, this is a good question. Can utilities interpret fields differently? I understand they have guidelines on how to do that by FERC and NARO guidelines, but I have seen they can be inconsistent. And yes, yeah, they can be incredibly inconsistent. I will say that the accounting tables, in particular, maybe because accountants are meticulous, and maybe because, and because like that they are, the accounting tables largely mirror what they have to, how they have to, report their taxes, report their rate cases. Like the accounting tables are much more consistently reported, and there are the FERC's uniform system of accounts, which is like largely a rate making or a rule making, like it's a large regulation. It is quite clear about what should go into which category, and they are like financially liable to put particular assets in particular categories. So they're much more consistent in the asset table than they are in the account, in some of the accounting tables, than they are in anything else. Cool. Yeah. So for some of the inconsistencies, like with a lot of the the question was, are there any ways to deal with this inconsistency? For a lot of the plant tables, which are much more loosey-goosey in a lot of especially the text fields, we basically have like what we have done to knit the data across a bunch of years of data and across a bunch of the utilities so they are more comparable is we have like figured out what all of the ways in which how any utilities have ever reported plant kind, and we do, we pull that together in one place and we map what we think that means. So we just like build some shared taxonomy, and we do our darndest to interpret what utilities communicate appropriately. Yeah. I'll take one more question, then we should move on. But does FERC Form 1 include costs paid to comply with environmental policies? Yeah, I don't know which table off the top of my head they report that kind of information in, but they certainly do report like compliance costs especially across a lot of some of the accounting tables. But even some of the like some of the plant tables incorporate the capital costs that I was talking about. Like a lot of the plants in the late aughts were required to put on a much more emission control equipment. And though that is that is very capital intensive, and you can see that across the board in the capital editions of the plants. Although they are not for plant by plant, it is not like spelled out specifically that like this is the capital cost. It is just like lumped in with an annual capital edition. So it's a little less specific in those plant tables, but it is clear when a coal plant got a big scrubber basically from the data. So, right. I will pass it off to Ella to talk about CEMS, which is very different data set.
Something completely different. So yeah, I'm going to talk about our last data set that we're going to cover today, which is EPA's CEMS, or the Continuous Emissions Monitoring Systems data. So the EPA, or the Environmental Protection Agency, was created in the 1970s. It's responsible for conducting environmental assessments and monitoring and setting federal environmental standards. So, for example, like banning usage of a particular chemical or setting limits on particular emissions. And they work with state and local governments to enforce these regulations. Next slide. So when EPA passes regulations targeting power plants, how do they actually enforce them or monitor them on a plant-by-plant basis? CEMS is one of the tools that they use to do so. It's basically a series of sensors and machines that they force plants to install on a smokestack. So Part 75 of the Code of Federal Regulations, which is the backbone of the Clean Air Act's Acid Rain program, required any unit greater than 25 megawatts in capacity that was burning fossil fuels to install and use a continuous emissions monitoring system. These monitoring systems collect and report data about the sulfur dioxide emissions, nitrogen oxide emissions, and carbon dioxide. They also report the types of controls that are in place on the smokestack. So like, for example, what kind of technology is being used to reduce nitrogen oxide emissions. They also report heat input and gross load, as well as the percentage of each hour that the unit is operating. And this data is used by the EPA for enforcement. But it's also used by researchers and community activists as well. So because it's used for enforcement, accuracy is really key, but there's also like an interesting environmental justice relevance to this data that will come out in some of the examples I'll talk about later. The CEMS data covers the US and Puerto Rico. I remember someone was asking about Alaska data. There is more recent Alaska data, like last 4 or 5 years or so, since 2018, I believe. But some states go all the way back to 1995. The data is reported at an hourly basis. And the unit of reporting is the smokestack itself. The data is collected every quarter and released about 2 months after the end of the quarter. And like all the other data sets that we've talked about, it's a US government data set, so do with it what you will. Very differently to EIA and FERC, which involve a lot of humans typing things into spreadsheets, CEMS is a pretty mechanical form of data collection. So it's basically a collection of monitors and probes and data loggers and this thing called a data acquisition and handling system. What it does is take the data from all the different sensors, translates it into the correct units, and does missing data substitution on an automatic basis, records and then stores all the data. So the level of human interference and like an ongoing level is far lower than we see in EIA or FERC. There's not some guy typing in like, this is the plant name. The EPA publishes what it calls a plain language document. And this is like a bit of a misleading thing because it is extremely technical and dry to read, but it's less technical than reading like the regulation itself. But this basically spells out like all of the aspects of the CEMS program. What are the quality assurance and quality controls protocols that are used? How do you certify a sensor? How do you handle missing data calculations? What do you do if a sensor goes offline? What kind of backup protocols do you need to have in place? And again, because the data is used for monitoring and enforcement, the consequences of the data being wrong are potentially high. So there's a really high emphasis on the quality of the data. We link to the plain language document in a couple of slides, and I'll just say that if you're going to use this data, it's like an interesting document to look through. It gives it's a lot more transparent than some of the other data sets that we use. And this data is reported quarterly, so there's a client tool that the EPA uses, and it provides some kind of automatic screening upon the upload of data. If there's a major quality issue, the EPA can assign an analyst to work with a submitter to try to resolve the problem or figure out what's going on. In terms of how the data is used, so I'll give an example, and the creator of this project actually happens to be on this call, so I will direct, hi Greg, I'll direct detailed questions to him, but I'll just say that there's like increasing interest in understanding how the usage of electricity corresponds with greenhouse gas emissions. So for example, the Security and Exchanges Commission now requires companies to report emissions associated with their energy purchases. The way that they do this, though, is based on the annual average emissions of the balancing authority that the company is in. So companies use EGRID, what's called the Emissions and Generation Resources Integrated Database, yearly averages to do this. They basically say like, this is how much electricity I use. This is like the annual average. We'll just like multiply this together, and this is my emissions for the year. And the problem is that this excludes like really huge fluctuations in the emission rates over time. You can see in the chart on the right, which thank you, Greg, that the emissions rate can vary really substantially, like within a day, within a season, and over the course of a year. And so Open Grid Emissions is one of the projects that's trying to make it more possible to understand how emissions are produced by electricity production over time. It uses CEMS data where it's available, and where it's not, it combines both EIA 923 and 930 data to create a validated hourly emissions profile. And you can use this data to really start to think about the marginal emissions associated with energy usage at any particular point in time. So it's a very cool project and also open source, and highly recommend checking it out. Another, thank you, Greg. Another application of this data is as a source of validation. So this is a paper that's published in PNAS this summer. And they were using Landsat and Sentinel data to look at point source emissions in the US, and they needed something to compare their work to. So CEMS provides a very clearly measured record of point source pollution at a particular plant over time, so they can compare the satellite data and their estimates from that to the CEMS data itself. And finally, I said before that this data has some kind of interesting environmental justice applications. So I just want to highlight one example of community group actually using this data. So in 2021, advocates looked at Xcel's Pawnee coal plant in Fort Morgan, Colorado, and they saw that the CEMS data was indicated that the plant was violating the limits of sulfur dioxide emissions hundreds or thousands of times over the course of several years. They basically use this information, all generated from publicly accessible data, to launch a complaint to the EPA, basically claiming that the Colorado state agency responsible for enforcing the limits was not actually meeting the EPA's criteria. So kind of an interesting example of like a non-research, let's say, like a more grassroots usage of this data. In terms of inconsistencies and challenges, as I mentioned before, this is like a fairly high quality data set. So most of the challenges have to do with like handling it and what's not in it, understanding it. So it primarily it's big. If you're looking US wide, 1/4 of data in CSV is about 2 gigs. That's like more than I can open. I can start to get the like, you can't load all the rows warning. So it's difficult to maneuver as a CSV if you're looking over like long timescales or if you want to do US wide analysis. For that reason, when we publish this data, we publish it as Parquet files, which are easier to query and to store large amounts of data. But it'll be difficult to analyze this data in just a spreadsheet without subsetting it quite a bit. The coverage is not complete. So first of all, CEMS only covers combustion-based generation. So renewables and nuclear are not covered by CEMS. It's not a complete picture of the grid itself. There are also lots of exemptions for who reports to CEMS or who's required to install like a CEMS unit. Generators that have 25 megawatts or less in capacity don't have to install CEMS unit. Generators that are units that are not selling their electricity or that are burning low sulfur fuels, or if you haven't upgraded your unit since before CEMS was required. So like if you haven't touched your unit since the 70s, technically, anyways, there's some exemptions there. Which means that some of the information that shows up in EIA data with the different reporting requirements that we talked about earlier does not show up in CEMS. So the chart below, which Greg, thank you, Greg, also made, shows like the gaps in coverage in terms of like what information is available in CEMS as opposed to the information that's covered by EIA 923. And so we see that like coverage of CO2 emissions, SO2 emissions is relatively high, around 90% shows up in CEMS at an hourly level. But this can vary quite a bit regionally. So in CAISO in particular, we see that there's a lot of reported nitrogen oxide and sulfur dioxide emissions that show up in the EIA data, but not in CEMS. So it can be a mistake to relate to CEMS as like a complete picture of all of the emissions of the entire US electricity system. And so it's important to pay attention to that coverage there. And the last thing I'll mention that Austin will talk about more in a moment is just that the EPA is concerned with the release of emissions. So for them, a unit is a smokestack, like it's the place where the emissions are released. Other data sets that we've talked about are much more concerned with electricity generation. So for them, the unit is really like focused on the generation level. So making those two data sets talk to one another can be a bit complicated. But yeah, there's a ton of links here. I'll just leave them for you all to consult later. I'll just flag that the like plain English version of the document is the last link there. I'd recommend checking that out. So yeah, any questions for me? I see one already, which is just where do you recommend looking for a more complete picture of emissions that looks similar to CEMS? I would recommend really actually looking at the Open Grid Emissions Project, which has done the work of trying to fill the gaps of CEMS with the EIA data that's available. Yeah, I think that's a really good starting place. If there's any other questions. give you all a minute to think. Okay, hearing none. I'll just say that we'll have time for questions at the very end, so if anything pops up, I'm happy to chat more too. So yeah, we've been talking about different data sets, different different agencies, different programs, different data standards and interests. But ultimately, these data sets are all actually referring to the same physical infrastructure, the same entities, the same utilities. And so we can combine these data sets together to get a more complete picture of the electricity system rather than treating each one as a silo. I'll hand it off to Austin to talk about the connection between EPA and EIA data.
Thanks, Ella. So before we get into some of the deeper connections between these different data sets and data publishers, it is helpful, I think, to look at a schematic of an example power plant. So this is a combined cycle power plant. There's a lot of different boxes, triangles, arrows here that all relate to each other. And each power plant is a special snowflake. It's interesting when we refer to them as plants, as data practitioners, it's very easy to think of them as points in time, but they're very complex entities that have different points of measurement, as Ella was mentioning before. So just taking in the components of this is helpful in understanding how complex it can be to relate different data sets to one another and different publishers. So in particular, the EPA is concerned, as Ella mentioned, with the emissions, which are associated with a given smokestack, whereas EIA is collecting information about electricity generation. So that would be recorded at the electricity at the generation unit. And relating these entities together isn't always straightforward. There's often a one-to-many or many-to-many relationship between these entities. So the image on the right is depicting an instance where you might have two gas turbines and an oil or a diesel generator that are somehow connected to these two smokestack outputs. So if you wanted, for instance, to associate emissions with a particular generator or a particular source of fuel, you wouldn't be able to do so in this instance because you can't extract the emissions that are going to smokestack B and smokestack A and determine definitively which generator they're coming from. So in this case, you wouldn't actually have a granular information about emissions as you might want, and you would have to aggregate up the information to associate the emissions or the EPA information with some of the EIA information. So it's important to note it's not always one-to-one. Luckily, the EPA publishes a table for us called the EPA EIA crosswalk that connects these EIA unit IDs with the EPA unit IDs. So that's not something that we have to do, or unlike some other data sets that don't have any predefined relationship between one another. But it's important to note that it is not always going to be at the level of granularity that you might want.
Great. Great segue into maybe dragging FERC again. I'm going to cover quickly a connection between EIA and FERC at the plant and subplant level. So just a quick recap, as Austin and Ella were mentioning, EIA reports and really cares about the generating unit, which is a combination of boilers and turbines and generators that are working together as one individual unit to generate electricity. And EIA data has unique IDs for all of those individual components of an electric unit, of an electric generating unit. And as Austin was mentioning before, there's a decent but not entirely complete association between generators and boilers that form these units. EIA also has a ton of attributes that they report pretty consistently that you can use to pretty easily group like or similar connections of generators at a plant. So you can pretty easily say what are all of the the combined cycle units or generators at this plant, or what are all of the generators that are using coal as a primary fuel source at this plant, and on and on. On the other hand, FERC is a bit of a trash fire about this. There are no shared IDs. There are no FERC in the plant tables. The utilities irregularly report an inconsistent portion, like either whole plants or portions of plants. These are a few examples of how just two utilities report to to just the steam table alone. So there's whole plants in here. There's technology types. This like Asheville CC is an example of a technology type that is being reported that we've been picking on this whole time. There are examples of prime movers in this table. So at the Asheville gas turbine is a prime mover. The Asheville steam is a prime mover. And then there are also instances of collections of units or generators, ? In this Excel example of Cherokee 4 and Cherokee 5, 6, and 7. So FERC is irregularly reporting portions of plants, which is annoying, but solvable in some ways. So we have done a lot of work trying to generate a super detailed granular connection between FERC and EIA, between these like plant parts that are reported in FERC. So we have done this by using a machine learning model, and we have found that like, while the vast majority of FERC records are reported at the plant level, about 70% of them, another 30% are reported at this more granular or detailed level. And that's particularly important in cases in which, say there's a gas plant and there's a gas unit and a coal unit, for instance, located at the same plant, because that gas unit and the coal unit are going to have very different operational characteristics. They're going to burn fuel really differently. They're going to generate emissions very differently. And as much as possible, if we can disentangle that information and get the information at the like most detailed level, it helps get more accurate information about plants. And the reason that we cared about connecting FERC and EIA together is because with the like relatively nice clean data in EIA, and has a bunch of attributes that are like clear definitions and all the things, and as well as the fuel costs and fuel consumption that is reported in EIA, paired with those non-fuel operational expenses and capital costs, you get a much more complete picture of the financial and operational characteristics of a plant at the most granular level. Yeah. Great.
We'll return to questions time in a second. So if there's any questions that you have about anything that we talked about, anything we didn't cover, if there's a question that you asked that we didn't answer, we'll have time at the end to just chat. But before we do that, I just want to say thanks for coming. If you want to stay up to date about future seminars, other programming that we're putting together, we have a workshop listserv link that Christina just shared in the chat. It's just a Google group, pretty low traffic. We also host weekly office hours if ever you want to come ask us questions about our data or any other energy data that we know about, or chat about your data problems or whatever schema project to work on together, and we're really happy to talk. And then finally, there's a link to a feedback form. It's really helpful for us to know like what went well, what didn't, what you're interested in hearing about for the future seminar. So if you can take like 2 minutes to fill that out, it'd be really helpful for us. Yeah, thank you all. And we'll come back to questions now. And as a reminder, we'll share those slides with you all over email. So, and we'll put the recording online as well with some Zoom bombing editing. So yeah. So yeah, I'll open for questions again. There is one question just about pressure for FERC to clean up these data streams. Yeah, Austin answered this a bit. But yeah, that it seems like they don't really see their primary audience as like end users of the data. And they genuinely sometimes seem surprised that people are using their data or able to use their data at all. But more people contacting them and requesting higher quality data is never a bad thing. Christina, do you want to take this question about FERC 1 data?
Yeah, definitely. The question is, does FERC 1 data include data, especially capital costs for power plants in restructured power systems? And I believe that's asking the like restructured states. So the states where there's a break between the generation and transmission and distribution side of the energy system. And the answer is yeah, they definitely, FERC does not like if you are an operating entity that operates within the limits of a major utility, you have to report. So some of the like small generators in the restructured systems that like don't have sales or exchanges over that limit do not need to report. But the larger entities do. So FERC does not make the distinction between where you are in the US in terms of if you need to report to Form 1. But there is more of a drop off in the restructured states just because of the size requirements and the ability in those states to like kind of bifurcate.
Any other questions for us? Feel free to also raise your hand or unmute if you want to ask a question. Thanks, y'all. Really appreciate it. And yeah, I'll just say as people trickle out, I think our next seminar will be in January. Stay tuned. And subject still TBD, but may or may not feature guest speakers.